Of Unit 8. Unit 8 is all about polynomials and factoring. And in this video, we're going to talk about learning target 8A, which is adding and subtracting polynomials. By the end of this lesson, you will be able to find the degree of a monomial, add and subtract polynomials, as well as write a polynomial in standard form, then classify that polynomial based on the degree and the number of terms. So as we begin off this unit, we do have quite a few vocabulary words that we have to go over just so that we have some terminology to use throughout the rest of this unit. So our first vocab word is what a monomial is. So a monomial is a real number, a variable, or a product of a real number and one or more variables with whole number exponents. So that last part about whole number exponents is going to be key as we start creating a list of examples and non-examples. So one example of a monomial that we could have is just a constant. So the number 18 is a real number, and that is therefore a monomial. The other thing I could have is just a single variable by itself. So a would be a monomial. I could also have a product of a real number and a variable. So let's say negative 4x to the positive 2. That would be an example of a monomial because here my exponent is a whole number. Another example, if we want to get fancier, could be 1/3 x times y to the 4th. So I could use more than one variable as long as their exponents are whole numbers. So it's okay if I have fractions as my coefficient, because that is still a real number. I just need my exponents to be whole numbers. So in our last unit, when we dealt with rational exponents, that's something that's actually not a monomial. So for example, x to the 1/3 would not be a monomial because the exponent here is not a whole number. Another example that is, another non-example could be x to the negative 3rd. In this case, that is not a monomial because my exponent here is a negative number, and by definition, whole numbers are all of our positive integers. So just as a little reminder there, our whole numbers are our positive integer values. So these two, x to the 1/3 and x to the negative 3rd, are what we're calling non-examples. These are not monomials. And that is because their exponents are not whole numbers. Our next definition is what the degree of a monomial is. So the degree of a monomial is the sum of the exponents of its variables. So the degree of a monomial is the sum of the exponents of its variables. We do have one special case, and that's that the degree of a non-zero constant is actually equal to 0. So as we saw in our list of examples up here, 18 is a constant, so it's just a real number. So we would need to define separately what the degree of that constant is, and by definition it is 0. Now the reasoning on why it really is goes back to our last unit actually. So 18 can be rewritten as 18 times x to the 0 power, because remember, anything to the 0 power is going to be equal to 1. So in this case, because my definition of the degree of the monomial says it's the sum of the exponents, well, if I rewrite 18 as 18 times x to the 0, my exponent then is 0, which is why we define the degree of a constant to be 0. Let's do a couple other examples. So in these first three examples, it says find the degree of each monomial. So we're looking for the sum of the exponents. In problem 1, we have 5x. So in this case, the degree here will be the sum of our exponents. Now we only have one exponent on we only have one variable, so we just have one exponent, and that exponent is equal to 1. So the degree of 5x is going to be 1. In our second example, we're finding the degree of negative 2. Negative 2 is another constant, so by definition, the degree of that constant is going to be equal to 0. In example 3, we have 1/3 times a to the 4th power. What do you guys think the degree of that monomial is? So the degree of 1/3 times a to the 4th power is going to be 4, since that's my only exponent, so there's nothing else to sum with it. As we move on, we're now going to start practicing adding or subtracting monomials together. And we do this by adding and subtracting like terms, like we've done in past units. So our first example says simplify 3x squared plus 5x squared. So again, remember, when we're simplifying like terms, we're just adding or subtracting their coefficients. So I'm adding 3 plus 5 of them, so I end up with 8x squared of them. So the x squared piece does not change, since that's the amount of something that we are looking at. In example 5, it says 4 times x to the third y minus x to the third times y again. So we do have like terms because I have an x cubed y and another x cubed y. So what we're looking at is combining our coefficients. So I have 4 of them minus, technically there's that invisible 1, so minus 1 of them, which would give me a total of 3 of them. So I'd get 3x to the third y then. Why don't you pause the video and try example 6 on your own first? So in example 6, I do have like terms because they're both x to the fourth powers. So what we're going to end up doing is adding together our coefficients. So negative 6 plus 11 will give me 5x to the fourth then. Okay, we have a couple more pieces of vocab here. So our next piece of vocab is what a polynomial is. So a polynomial is a monomial or a sum of monomials. And standard form of a polynomial hold on, let me make sure it fits. So standard form of a polynomial is when the degree of the monomial terms decrease from left to right. Meaning I start with my highest power, and then as each term progresses, my powers are decreasing on each term. So one example of a polynomial in standard form is 3x to the fourth plus 5x squared minus 7x plus 1. So that polynomial is in standard form because as I look from term to term, the degrees are going down. They don't need to be consecutive. I could be missing some degrees, but they should get smaller in each case. So my first term has a degree of 4, my second term has a degree of 2, then my third term has a degree of 1, and then my last term, since it's a constant, has a degree of 0. So the powers start with the biggest and go down to the smallest. As from what we can see here is each one of these is individually a monomial, so a polynomial is just when I sum a bunch of those together. Now a non-example for standard form could be if I rearrange these in any other order. So what if I have negative 7x come first, then plus 5x squared, plus 1, plus the 3x to the fourth. Now this is not in standard form because I don't have my highest power down to our lowest power. So we would have to rearrange those, and to put this guy in standard form, it would look like our 3x to the fourth plus 5x squared minus 7x plus 1. Our next piece of vocab has to go back to doing with what degree is, but now we're going to talk about the degree of a polynomial. So before we were talking about the degree of a monomial, which is when I just have a single term, but if I have a polynomial now, where I'm adding together a bunch of terms, we want to be able to define the degree of the polynomial. By definition, the degree of a polynomial in one variable is the highest exponent. So if we're in standard form then, our degree is going to be that first term's power, since that would be my highest exponent. So for example, the degree of this 3x to the fourth plus 5x squared minus 7x plus 1 is going to be equal to 4, since 4 there is our highest power. We do have a couple other definitions, but we're going to learn about those definitions through a series of examples. So in this table down here, we're going to learn about the different names for degrees and the different names for terms using a couple examples. So let's look at our first example. It's a single constant, so we know the degree of a constant is equal to 0, and the name of that would then be a constant, which is what we've been calling it. In this case, I have one term, and we know that that is called a monomial. So remember, one term would make a monomial. In my next example, we have 7x minus 1. What would the degree be of this example here? Our degree here would be 1, since 1 is my highest exponent. We call this a linear function, which we've talked about linear functions before. The number of terms here is going to be 1, 2 of them, since I have 2 separate terms. And here comes kind of our next vocab word. This is what we call a binomial. So a binomial, by definition, is a polynomial with 2 terms. In our third example, we have negative 2x squared plus x plus 10. What would the degree be of that polynomial? Our degree here would be 2, since 2 is our highest exponent. We call this a quadratic polynomial, since my degree is 2. In this case, we actually have 3 separate terms. I've got the negative 2x squared, the x, and the 10, and we call that a trinomial. So by definition, a trinomial is a polynomial with 3 terms. In our fourth example here, we have 6x to the third. What would the degree be of that polynomial? Our degree here would be 3. We call this a cubic polynomial because the degree is 3. In this case, we're back to having 1 term. What do we call it if we only have 1 term? We call it a monomial. In our fifth example, it says 5x to the fourth minus 4x minus 7. What would the degree of this polynomial be? Our degree for this polynomial is going to be 4, since 4 is our highest power. We don't have a special name for this, so we just call it a 4th degree. So once you hit your highest power being 4, meaning our degree is 4, or any power higher after that, we don't have any more special names, so we just call those 4th degree, 5th degree, 6th degree, 7th degree, and so on. In this example, we have 3 terms again. So what do we call it if we have 3 terms? We call it a trinomial. And in our last example down here, what would the degree of that polynomial be? Our degree here would be 3, since 3 is our highest power. So we call this a cubic polynomial. And we have 2 terms, so we really do call it a binomial then. So through this table, we can kind of see how we could name some of these polynomials. So in our first example with 5, we would call that a constant monomial. In our second example, we would say that 7x minus 1 is called a linear binomial. In our third example, negative 2x squared plus x plus 10 is called a quadratic trinomial. 6x cubed would be a cubic monomial. Then 5x to the fourth minus 4x minus 7 is called a 4th degree trinomial. So if we don't have a special name, that's okay. We'll just call it the nth degree. So in this case, the 4th degree, and it's a trinomial. And then in our last example, negative 7x to the third plus 10x squared is called a cubic binomial, since we have a degree 3 and we have 2 terms. We're going to go through some examples next where we practice writing our polynomials in standard form and then naming them based on the degree and the number of terms. So that's where these new vocab words of a binomial, trinomial, and then in case you haven't seen them before, a linear, a quadratic, a cubic, and any higher than that, we'd call it a 4th, 5th, 6th, 7th degree as we keep going. The other thing I should mention is if we have more than 3 terms, we don't have a special name for that. So if we have 4 terms or more, then we just simply call it a polynomial. But for these first 3 special cases, 1 term is a monomial, 2 terms is a binomial, and 3 terms is a trinomial. Okay, let's do some practice with these. So our instructions say, write each polynomial in standard form, then determine the name based on its degree and the number of terms. So remember, standard form means the highest power first, all the way down to the lowest power. So in each of these, I might need to combine some like terms, maybe I need to do some rearranging, but we've got to move stuff around to get it in standard form. So let's start with our first example. So example 7 says negative 3x plus 5x squared. As that stands right now, is that in standard form? So this guy is not in standard form because my highest power, which is the 5x to the second, would have to come first. And then, since I only have one other term, would then come the negative 3x. Now this is in standard form since I go highest power down to smallest power. What would the degree be of this polynomial? Our degree here would be 2, since that is our highest power. How many terms do we have? So in this case, we have two separate terms, the 5x squared and the negative 3x. So I have a degree 2, and my number of terms is also 2. So that is called a quadratic, since the degree is 2. And because the number of terms is 2, we call it a quadratic binomial. So our name for this guy is going to be a quadratic binomial. Okay, let's look at example 8. It says 4x minus 1 plus 5x cubed plus 9x. Why don't you guys pause the video and put that example in standard form first, and then we'll check it together. Okay, let's check putting this guy in standard form. So my highest power has to come first, so that would mean the 5x cubed comes first, and it's positive because of the plus sign in front of it. So I've taken care of that guy, I can kind of check him off. The next term that would come would be any x to the second powers, but I don't have any x squareds. So the next thing that comes is our x to the first, but I actually have two places with it. I have a 4x and I have a positive 9x. What that means is I first need to combine those like terms before I put it into standard form. So 4x plus 9x will give us 13x. And then our last term to take care of is the negative 1. Now that this polynomial is in standard form, why don't you guys pause the video and find the degree and the number of terms. So the degree for this polynomial is going to be 3, since that is our highest power. And we also have 3 terms in this case, the 5x cubed, the 13x, and the negative 1. Based off of the fact that the degree is 3 and the number of terms is also 3, why don't you guys come up for the name of this polynomial? So this polynomial is going to be called a cubic because the degree is 3, and then since I have 3 terms, we call it a cubic trinomial. Okay. Let's look at example 9. So example 9 says 6x minus 3x squared minus 4 plus 10x squared. Why don't you guys pause the video again and come up with standard form, and then we'll check it together. So for standard form, I have to start with my highest powers, which would be the x squareds in this case, but I first need to combine my like terms. So negative 3x squared plus 10x squared would give us 7x squared. The next term that's going to come is the positive 6x, and then the negative 4. Why don't you guys pause the video and find the degree and the number of terms. Okay, let's check this. So the degree here would be 2, since 2 is my highest power, and I have 3 terms this time. What would we call a degree 2 with 3 terms? We would call this a quadratic trinomial. So quadratic because the degree is 2, and trinomial because there are 3 terms. Okay. Let's move on to our last section. So our last section is kind of how can I combine and add multiple polynomials together? So in examples 10 through 11, what we have here is we're adding or subtracting 2 polynomials together. So our goal is to simplify these, and we also want to make sure we're writing our final answer in standard form. Looking at example 10, it says negative 4x to the third minus x plus 10 plus 4x squared plus x minus 13. Well, in example 10, do you guys think the parentheses are necessary, or are they not doing anything right now? So these parentheses are actually not doing anything. There's nothing to distribute, there's no numbers in front of them, so I could just drop the parentheses. So if I drop the parentheses, we get negative 4x to the third minus x plus 10 plus 4x squared plus x minus 13. Now from here, my goal is to combine like terms, and I'm going to start with the highest power down to the lowest power, so I'm also putting it in standard form at the same time. Our highest power is the x to the third, and there's only one of those terms, so I'll start with a negative 4x to the third. My next term, so I'm going to check these off as I go. Our next term is going to be the x squareds, and we only have one place with an x squared. So I'll write plus 4x squared since there was nothing to combine that with. The next terms are coming from the x's. So I have negative x plus x. So I'll write both of those. So negative x plus x. Then the last is the constants, and I have plus 10 and a minus 13. So this is not quite in standard form yet because I still need to combine some like terms. The negative 4x cubed and the positive 4x squared cannot be combined with anything. But negative x plus x, I could add those together and they would actually cancel each other out, so I'm going to have no x's then. My last piece is to add 10 minus 13 will give me negative 3. So here is our simplified answer in standard form. Okay, let's try number 11. So in number 11, it says a to the third minus 6a squared plus 8a minus the quantity 7a cubed plus 3a squared minus 11. So what do you guys think? Are the parentheses doing anything here, or can I just drop them like we did before? So in this example, I cannot drop the parentheses because I need to distribute the negative sign. So I can drop the set of parentheses on the first polynomial, because nothing's being multiplied in. But on the second polynomial, I need to distribute that negative sign. And I'd end up with negative 7a to the third minus 3a to the second plus 11. From here, now I can start combining some like terms. So I have an a cubed and a negative 7a to the third. So I'm going to combine those, and I'd end up with negative 6a to the third. The next highest power is our a squareds. So I have a negative 6a squared and a negative 3a squared. So I'd end up with negative 9a to the second power. I also have a plus 8a, which has no other like term. And then the last piece I have is my constant, so we end up with plus 11. So we both simplified and put that into standard form at the same time. Why don't you guys pause the video and try example 12 on your own first, and then we will check that together. Okay, let's check example 12. So in example 12, I have a polynomial plus another polynomial, so I can just drop the parentheses, and I get 10a to the fourth plus 2a squared minus a plus 1 minus 2a to the fifth plus 3a squared plus 9a plus 5. From here, I'm going to combine like terms and put them in order from highest power to lowest power. So my highest power here is going to be the negative 2a to the fifth, and there's no other like term to combine them with, so I just have negative 2a to the fifth. There we go. The next highest power would be an a to the fourth, and we've got one of those, which will be plus 10a to the fourth. Next would come our a to the third power, but I don't have any, so I'm going to skip down to our a to the second, and in this case I have two of them. I have 2a to the second plus 3a to the second, so combining like terms, I get plus 5a to the second power. The next spot would be our linear term, so our a to the first, and I have negative a plus 9a, so I'll end up with positive 8a then, since I have 1 plus 9 of them. Then the last piece I have is my constants. I have a plus 1 plus a 5, so I end up with plus 6 then by adding those together. And that will be our final answer, which is simplified and in standard form. Okay, last example. Why don't you guys pause the video and do example 13 on your own first, and then we will check that guy together. Okay, on example 13, we do have to worry about our parentheses here because I'm subtracting, which means I do need to distribute this subtraction sign, or that -1, to every single term first. So I'm going to rewrite the first polynomial, and then on the second polynomial, I'm going to be careful to make sure I distribute. So I'll end up with -3x to the third minus 4x squared plus 2x minus 2. Now from here, I can start to combine some like terms, and I'm going to do that by starting with our highest powers first, so I'm also putting it in standard form. Our highest power will be the -7x to the fourth, and there's no other like term, so I'll just get the -7x to the fourth. The next highest power is our x cubes, and we have 10x cubed minus 3x cubed, so I'll end up with plus 7x cubed. My next highest power is the x squareds, and we have -x squared minus 4x squared, so we end up with -5x to the second. Oops. That should be a 2, so -5x to the second. The next piece we have is our linear terms. So our x to the first, I just have one of those, so I get plus 2x. Then the last piece is my constants, and I have plus 2 and then minus 2, so those actually cancel each other out, and I'm not left with any constants. And that would be our standard form for that last polynomial. So in this section, we did have quite a few vocabulary words that we learned about. We learned what a monomial is, what a polynomial is, and then some special cases of those like a linear polynomial, quadratic, or a cubic. We also learned about a binomial, which is a polynomial with 2 terms, a trinomial, which is a polynomial with 3 terms, and then we talked about standard form going from the highest power down to the lowest power, and that the degree of a polynomial is that highest power.